Hello everyone, myself Pradipon. Today I am here to present a topic of distributed soft video transmission based on hybrid digital and analog scheme. Introduction to distributed soft video transmission. Distributed soft video transmission aims to enhance video quality while minimizing bandwidth usage. This methodology leverages both digital and analog scheme to optimize performance. It is particularly useful in environment the variable transmission condition. With the rapid advancement and miniaturization of video capture devices, the Internet of Things is witnessing a surge in the transmission of multimedia content. As the advanced digital compression algorithms carry a huge burden, hardware ports have been used to reduce the coding delay. Understanding hybrid and digital analog schemes. A hybrid scheme combines the strength of both digital and analog transmission method. Digital transmission offers superior error correction capabilities while analog can be more efficient in certain scenarios. This combination allows for flexible adaptation to varying network conditions. Key components of the system. The system consists of source encoder, a channel encoder, and a transmission medium. Source encoding compresses video data, while channel encoding adds redundancy for every correction. The transmission medium can be wired or wireless depending on the development scenario. Benefits of distributed transmission. Distributed transmission allows for the sharing of resource across multi-nodes. It improves reliability by utilizing multiple pathways for data delivery. This approach can also reduce latency and enhance user experience in video streaming applications. Soft decision coding. Soft decision coding utilizes probabilistic information to improve error correction. This technique contrasts with hard decision decoding, which allows makes binary decision. Soft decoding can significantly enhance performance in challenging transmission environments. Video quality assessment. Quality assessment is circularly for evaluating the effectiveness of the transmission scheme. Metrics like peak signal to noise ratio and structure similarity index are commonly used. These metrics help in determining the perceived quality of the transmitted video. Softcast. In softcast, the discrete constant transform is applied to the group of picture and energy is concentrated in the low frequency region of the GOP. Neighbor spectral discrete constant transformation are divided into chunks. The mean of each chunk is subtracted from each coefficient to calculate the chunk average. Chunks whose average energy is less than threshold value are discarded. Distributed video coding. DVC is a fascinating compression scheme that transfers the complex motion estimation and compression algorithms to the decoder. In other words, DVC fully utilizes enter-frame correlation at the decode, where DVC achieves a lightweight encoder. It is well known that a GOP of a video is divided into the frames and intra-frames. Proposed framework. The encoder of the proposed framework with the first input video frame is divided into several GOPs. A GOP comprises an first frame followed by a several P frame. The first frame are encoded and decoded with the soft cast. First, the DCT is used to obtain the frequency domain coefficients. Power is allocated between coefficients in different frequency domains and the ADMA transformations is applied on efficient to resist in the influence of packet loss. The 2D DCT is used to obtain the frequency domain coefficients of P frames, and the coefficient of P frames are divided into n chunks of equal size which are regarded as Gaussian sources with different variances. HTA based soft transmission. Different from other HDA coding schemes, both the digital and analog components of our HTA coding adopt precode analog modulation. In particularly, for n source vectors, we perform scalar uniform quantization on these n sources vector to obtain n Internet of Things quantization value vectors Ti and n quantization errors vectors 1 lesser than equal to I lesser than equal to n, where the quantization value corresponds to the coefficient of the digital part and the error correspond to the coefficient of the analog part. For the nth quantization, the quantization value Ti and the quantization error can be calculated with these formulas. Power allocation model validation. In this test, we validate the effectiveness of the proposed power allocation algorithm and the PNO. For the training progress, we generate 40,000 entries and split them into training set and test sets in the ratio of 4:1. The training batch size is set of 1000. Adam optimizer with the initial learning rate is used in the training due to well-known high performance. The number of layers is set to 5 and the node number of hidden layers is set to 128. We validate whether the estimated distortion at the encoder can truly reflect the actual distortion. If not, the proposed algorithm can still improve performance. We analyze the performance of a parallel Gaussian source in the scheme. Challenges in transmission. Variable network condition can lead to packet loss and delays, impacting video quality. The choice between digital and analog scheme can affect reliance and efficiency. Balancing complexity and performance is key consideration in system design. Applications of the hybrid scheme. The hybrid scheme is applicable in various fields including live streaming and teleconferencing. It is also beneficial for remote monitoring system and real-time video analytics. The flexibility of the scheme makes it sustainable for both urban and rural developments. Future trends in soft video transmission. Emerging technologies like 5G and AI-driven encoding techniques will, will enhance transmission applicabilities. Research is ongoing to improve adaptive algorithms that can dynamically switch between digital and analog mode. Future systems may also incorporate machine learning to predict and transmitting issues. Conclusion part. Distributed soft video transmission using hybrid scheme present a promising solution for video delivery. As technology evolves, future improvement in efficiency and quality are unaccepted. Continued research and innovation will be key to overcoming current challenges in the field. Thank you for watching the video.